So today we're going to be doing Module 5, Topic 1, Lesson 1. It's a generational thing. We're going to do the Getting Started, Activity 1.1, and Activity 1.2. Learning goals, we're going to expand a power into a product and write a product as a power. Let's start with the Getting Started. Okay, so Jake adopted an English Mastiff puppy that he named Rickson. The breeder provided documentation that verified Rickson's lineage for 3 generations as shown. Dog breeders actually do this. I have a girlfriend who recently bought a dog, and they provided her with a binder full of the dog's lineage and background, the dog's parents, the dog's grandparents, and the great-great-grandparents. And a dog's lineage is similar to a person's family tree. It shows a dog's parents, grandparents, and great-grandparents. All right, so it's pretty easy here. How many parents does Rickson have? He has 2. And they are Cody and Bella. So this is just helping you to identify, how to read that lineage there. How many grandparents does Rickson have? He has 4. So those are the grandparents there. How many great-grandparents? He has 8. So we went from 2, 4, 8. What pattern is there in the number of dogs in each generation? The number of dogs doubles each time. I'm going to go ahead and fill this back in. It deletes when I go back. All right. So expand notations like what we saw at the bottom, where 2 to the 7th, and they wrote out 2 times 2 7 times. So for the first one, it's going to be 2. And then we have 2 times 2. 2 times 2 times 2. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2. Perfect. And then question number 3, it says to label the 4th column of the table power, and then fill it in. So the power for the first one would be 2 to the 1st, then 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. Because again, 2 was our base. The exponent was how many times we were multiplying that number by itself. Please raise your hand and pause the video at any point if you have any questions. All right, you're going to use this information out to answer numbers questions 4 and 5. So how many dogs are in Rickson's lineage in the 12th generation back? Write your answer as a power, and then use a calculator to determine the total number of dogs. And then number 5, how many total sires and dams are there in all 3 generations shown in Rickson's lineage? All right, for number 3, you should have 2 to the 12th, which equals 4,096. And number 5, there are a total of 14 sires, and dams. Let's go ahead and add that in there. In the first 3 generations. So if there's 14 total, there's 7 sires and 7 dams. All right, let's move on to activity 1.2. On page 11, in this activity, you will investigate the role of parentheses and expressions containing exponents. All right, number one, there's a lot that we need to do here. We first need to identify the bases and exponents, write each power as a product, and then finally evaluate the product. So we've got three things we need to do. So in letter A, we are going to identify our base, which is 5. Our exponent is 3. When we write the power as a product, that's our expanded form. So 5 times 5 times 5. And then evaluate the power. So what is 5 to the third, or 5 times 5 times 5? It's 125. In letter B, now we need to pay close attention to letter B and letter C because of those parentheses. So in letter B, our base is -9, and our exponent is 5. So that means when we write this out, we're going to write -9, multiply it by itself 5 times. Finally, we want to simplify that or evaluate the power. You can use a calculator for this part. You're going to get -59,049. Now, which is very different from letter C, because in letter C, your base is actually 11. Reason being is because it doesn't have that parentheses around the negative. So when does that negative come into play? We're going to think of that as a -1. So then we're going to multiply, 11 times 11 times 11. So we get -1,331. Letter D, we actually have two bases in letter D. They are 4 and 3. And then our exponents are 5 and 6. And 6. So when we write this out, we're going to write 4 multiplied by itself 5 times. 2, 3, 4, 5. I started to write the number 5. And then we're going to need it 3 6 times. So 1, 2, 3, 4, 5, 6. Last but not least, we are going to evaluate that. Again, you can use your calculator. You get 746,496. Okay, similar with number 2, write each as a product, then calculate the product. So it says write as a product. That means we're going to do our expanded form. So in letter A, again, your base is 1. We include that negative as a -1. So we want 1 to the second power. So 1 times 1. So we get -1. Letter B, our base is 1. We're going to use that negative. We're going to put that up front. Then we're going to do 1 to the third power. So you get -1. Similar with letter C. If you're seeing a pattern here. And again, letter D. Our base is 1. We include that negative out in front. So 1. Then we do 1 to the fifth power. So we get -1. Again, different from letter E, because in letter E, our base is -1. So when we write this out, it's going to be -1 times -1, which does give you a +1. In letter F, your base again is -1, your exponent's 3. So -1 times -1 times -1. That's going to be a -1. Because a negative times a negative is positive. A positive times a negative is negative. All right, letter G. We've got -1 to the 4th power. Our base is -1. So we're multiplying -1 by itself 4 times. Negative times a negative is positive. A positive times a negative is negative. Negative times a negative is positive. So +1. And then letter H. You get -1. So what conclusions can you draw about a negative number raised to an odd power? And again, keep in mind, we're talking about when it's in those parentheses, is that a negative power raised to an odd power results in a negative product. Number 4, what conclusions can you draw about a negative number raised to an even power? So going back and looking at letter E and letter G, again, we're looking at when it's inside those parentheses, when that negative is inside the parentheses. Well, a negative number raised to an even power results in a positive product. Oops, sorry. So that concludes our video for today. You're going to complete pages 1, 2, 3 of the packet. What you do not finish will be for homework. Thank you.